Hello, this is a presentation of the report that I created for the air quality data of Headingley for the year 2022's first 9 months. So let's go into the presentation. So the overview of doing this analysis is because poor air quality affects the body instantly and it is for long term. According to World Health Organization, around 7 million people have lost their life every year because of breathing contaminated air, and there has been a lot of research on relationship between air pollution and the beginning development and severity of sickness, indicating public awareness of its hazards. So this study explains how this contamination affects the environment, its causes, and how we can estimate the pollutant concentration using previous data that is available from the official website. Machine learning and deep learning algorithms have been used to implement this analysis. So, the main problem behind this is the respiratory hazards caused by air pollution. So that is why we want to examine the air quality for that. This report includes hourly statistics on Headingley's air quality for the first 9 months of 2022 from the website Air Quality in England. The Leeds Headingley curbside station measures the particulate matters and the oxides of nitrogen and checks the secondary factors like speed, temperature, and direction of the air. The research examines Headingley's quality of air for the first 9 months from, and the data has been obtained from Ricardo's Air Quality in England website. Machine learning and deep learning algorithms have been used to evaluate the data. We can find tendencies, patterns, and trends in the data according to the time series, and also we will get a broad picture of how air quality looks like in the first 9 months of 2022. So the motivation behind doing this research was because my university is situated here and I've been living here from January 2022. So I was wondering how much polluted the place is. Much research was also conducted throughout the pandemic season, and I was curious to see how the air quality changed after normalization. Jupyter Notebook, Google Colab, and Python platform has been used for doing this analysis. The aim of this research is to measure the degree of air pollution in Headingley area and around the period of January to September of 2022. First level of analysis is descriptive analysis, where we examine the air pollutants, descriptive statistics, which includes all the minimum and maximum value of the contaminants, the average standards according to the WHO standards, as well as the air temperature. We have also plotted the monthly air quality index. In inferential statistics, we are doing hypothesis test, one-way ANOVA test, and two sample t-test, and we compare the averages of 2.5 levels over the study months, as well as we compare 2.5 particulate matter and 1.0 particulate matter levels in the atmosphere and how significantly different they are from each other. We also check the correlation between each of the pollutants. In machine learning analysis, we are implementing multilinear regression, support vector regression, random forest, adaptive boosting, and multi-layer perceptron. And we are also clustering and classifying the pollutants into different levels and different AQI bands. In deep learning level of analysis, we are performing three algorithms, which is LSTM, GNN, and 1D CNN. Mm, and the components or the particles or pollutants that we have used for analysis the same like machine learning, uh, the ones that we choose for machine learning. In literature review, we can see that high PM 2.0 levels have caused so many deaths in China, which has also resulted in cancerous problems. Carbon monoxide, sulfur oxides, and nitrogen oxides have caused many respiratory issues. Most of these environmental issues are caused due to vehicular emissions. In another study, we found that several machine learning and deep learning based model simulations have been created for monitoring the air quality. Not only air quality, several other secondary factors like moisture, wind speed, temperature have also been estimated. And algorithms like decision trees, vector models KNN clustering, RDF, and logistic regressions have been used to predict the predict the levels of pollutants. We have used data mining methodology, which is known as the knowledge and data discovery. And except the implementation part, we have done all the levels in this methodology because we are not producing any product. This is just an analysis. So our product is actually the visualization and analysis results. There is no product implementation. Therefore, we are only using the first four steps of KDD. We also performed data pre-processing where KNN imputer was used to eliminate all the missing and blank values. So as I said in the descriptive statistics, we analyzed the basic statistical descriptions of the data. Inferential statistics, we measured variations. In the final two stages, we performed machine learning algorithm uh, on for estimating the PN 2.5 concentrations. Uh, and in the last level of deep learning, we performed three algorithms using the same dependent and independent variables. So after all the analysis was done, the findings said that deep data interpretation requires examining the number of data points, average, standard error, lowest value, maximum value, bottom interquartile values, middle value. All basic descriptive statistics were performed. The data was the average of PM10 concentration from January to September also exceeded the WHO's standard. The changing seasons prompted a considerable change in the average air temperature during the previous several months. 2022's yearly average air quality index dropped down in February and rose again in March, and then it fell again. Nitrogen dioxide emissions reached dangerously high levels, but it dropped in February. The nitrogen and PM10 levels were very high. It had a rise of 37 percentage in March. We're assuming that warm, bright weather and mild easterly winds might have been the reason for this immediate surge. In the hypothesis tests, we found that both of the null hypotheses were rejected, which means that the averages were not same. There were also certain correlations between the pollutants, like particulate matters were correlated to each other. They were correlated to nitrogen oxides. Nitrogen oxides were correlated to other secondary factors like direction, temperature, and air velocity. So this is the result of classification and clustering, and we got a 97% accuracy in the classification, which was a supervised classification, and that's the confusion metrics produced for that. From the algorithms that we perform, we can see that the least are the maximum R square values for MLP. So that was the most performed machine learning algorithm. In the deep learning, we can see that we have considered RMSE values for comparison, and 1D CNN outperformed of everything because it has the least RMSE value. So this is an unsupervised clustering where we can see that centroids have been randomly assigned in the beginning, and then we applied k-means algorithm, and it is divided into separate bands, and the centroids have been split into separate clusters as well. So in this research, deep learning performed better than machine learning, and we could get better outcomes if we improve the size of the data set. Most of the research was focused on particulate matters, and to discover the most widespread and persistent pollutants in a specific region, I would consider air quality data from different monitoring stations. Did not have any quantitative data. It was actually manually populated. There were not enough information about many other pollutants like sulfur, carbon monoxide, ozone, and hydrocarbons. Climatic air quality data can be checked to discover whether seasonal air differences have been caused due to this pollution. If we can expand the volume of the dataset, we will be able to study more about the pollution levels, especially in the working hours where more transportation is done, where people travel a lot. So in the future work, I would recommend using other machine learning algorithms which were not implemented in this, like the XGBoost. According to the literature, I saw that a picture-based deep learning system could be paired with CNN and regression classifier to forecast air quality. We can actually tune and tweak the hyperparameters to change the performance to do more trial and errors. Long term additional data from other sites within the same council may be acquired to compare air quality. We can increase the data amount to improve the descriptive and statistical information because huge data set gives more analysis, and it is also better to have big data set for performing ML and DL. So combining air quality data from different stations or expanding the duration of analysis would give a better result. That would be my ultimate recommendation. Thank you for watching, and this is all about the data analytics and visualization of the air quality data of Headingley. Thank you.